And gentlemen, welcome to the session on new retail peripherals and NFC HCE support in Windows 10. My name is Tony Goodhue. I'm a program manager on the IoT engineering team, and we're responsible for building all of the retail support and creating the additions in Windows that support things like IoT and the other aspects around the old embedded world and systems like that. With me, I have some members of the NFC HCE team, and I'll let them introduce themselves. Demet?
Hello, my name is Demet Bezmez. I'm a program manager in Windows operating system. I work on the NFC platform team. We have great improvements in the NFC platform this year, so I'll be talking over them on the second half of this speech.
And I'm Alex McKelvey. I'm the engineering lead for NFC across all the Windows platforms like Windows Phone and tablets and desktop.
Great, thanks. So at the end of this, I would like to thank you all for sticking around. This is the last session of the conference, I believe. So please make sure that you submit your evaluation at the end so that we can learn about how to make these sessions better and more align them with your needs and desires inside this type of event. So what I wanted to do was to give you a little bit of the themes that we had for our investments in Windows 10, both in the new retail peripherals as well as in the NFC HCE card emulation side of things. I'll talk about the new retail peripherals, and then Demet will be able to tell us more about the NFC HCE side. When we sat down to look at the peripheral support that we had in Windows 8.1 and where we should go, one of the key themes that we wanted to do was to actually enable mobile POS, to really let people be able to get away from a classic point-of-sale system that was all in one location, was located at the front of the store, and really help enable the newer types and the more innovative types of payment systems and experiences that are going on in a lot of stores these days, where individual people, individual sales clerks and so on, will have tablet or mobile devices and will move around those stores and interact with the customers where the customer actually is and where they're needing the information to assist in making their purchasing decisions. What we see moving forward is that a lot of the manufacturers out there building retail and point-of-sale systems will be looking to move into this space, and will do so by leveraging the current tablet markets and things that platforms that exist today, and then they'll be adopting what we refer to as a retail jacket model, where they'll be taking a jacket full of things like a barcode scanner, mag stripe reader, an NFC reader, and then they'll be taking that standard retail style of device and including it in that jacket. So that was one of the key areas that we focused on in this. And I'll go in across the various different device types that we support and how we supported that mobile POS area. The other thing we wanted to do was to continue to expand on the types of devices that are actually supported. And in 8.1, we had barcode support, we had mag stripe reader support. Now in Windows 10, we're adding support for receipt printers and for cash drawers, so that we can have APIs available for universal Windows platform applications that will reach all of those different pieces of hardware. For the NFC stuff, Demet?
We have improvements on the NFC platform. We have been supporting NFC since Windows Phone 8.0. And in Windows Phone 8.1, we opened up the WinRT APIs for doing card emulation, basically putting all these cards that we use throughout our daily lives onto the device on SIM-based card emulation. There was a lot of friction in terms of enabling SIM-based card emulation. So at the beginning of this release, we had one goal in mind. How can we open up these APIs to the third-party developers, merchants, banks, ISVs? The cards that we've been using throughout the day, like access badges to get into our offices, like bus passes to go to work, and then some loyalty cards, gift cards, credit cards. You can all put them onto your customers' devices by writing an app, a regular universal Windows platform app that your customers will be able to download and install from Windows Store. So I'll be going through the architecture and how you can build these apps for your customers in the second half of the session.
Great, thanks. So to put this all in context, what we want to do is to actually give you a little demo of the experience that a customer would have utilizing some of the new retail peripherals and our host card emulation support inside Windows 10. What we have here is a Windows 10 machine running a UWP application and talking to a set of peripherals here. We have a NFC reader, a receipt printer, a cash drawer, and a barcode scanner. We'll be utilizing a Windows Phone to be able to show the HCE part of this demo. So what I would like to do now is just actually take you through that, and you can see how a customer would interact with one of these self-checkout kiosks. So here's our kiosk. The first thing that we'd like the customer to do in our store is come up and swipe their loyalty card. Because with the loyalty card, we can get information about items they have on back order, the discounts that they should be given for products that they want to order, and tie into their details and our loyalty programs. So to do that, what we'd like to do is to use the loyalty card application that we have on our Windows 10 phone. So let me switch over to the screen.
So I already have my application here. And there it goes, my loyalty card.
And so here you can see that we've come into the application, and the loyalty card has been read, the NFC reader's fired off our event, we've caught that, and we're able to go and hit our services and understand that the customer has a number of items back ordered. So I'm going to select continue, and now I get to see the information about the item that I had back ordered. Dance Central 3, I've got one of those on back order, and so now I'd like to pay for that. And this is a fairly common experience that people have. They get some items, they go to pay for it, and they would use a barcode scanner that would most likely have a proximity sensor on it. You'd put a product underneath the barcode scanner, it would fire and read the barcode. In this case, I have a handheld item. So let me hit the barcodes that I have up here. And you can see that I've added a couple of items here. We've had the barcode scanner read the barcode, perform the understanding of the decoding of the barcode data, and fire an event off for us that enables us to then have our application respond to that. So now that I've done that, I'm all ready to check out. I'm going to click on and make a payment. There are usually many types of payment that can happen at a point of sale area. We can do cash, you can do credit cards. I could pull up a magstripe reader, swipe that. We again wanted to enable tap to pay as being something that we really want to do. So what I would do here is I would click on my NFC option, and in this demo we're going to bring up a dialog box. We wouldn't really do that in a real application, but we want to pause here for a second and then flip back over to our project the screen application so that you can see what is going on when you do that. So now we've gone and paid for it, and here what you've seen is that we've actually come up and been able to use the appropriate card, so that one application or the one phone device will surface both the loyalty card as well as the payment card. And Demet's going to go into some of the flexibility that you have as app developers in the second half of the talk. So now that I've paid for it, I would go in, I'd sign my name, and I'd click on Process Payment, and we would do our back office work. We'd go off, talk to the servers, go start processing the payment, and then we'd end up at the point where I would like to actually get a receipt. So I'd click on the Print Receipt button, and a receipt would print out. And I'd like you all to lean in a little bit so you can see that it matches. But that's the basic process that we go under. We can go and get a receipt, go through the process, payment, loyalty, read these devices, do barcode scanning. Let me go back and just show you very quickly how the cash drawer would work. Now, if you're familiar with the cash drawer model, they're typically connected to a receipt printer themselves. And in this particular case here, what I have is a cash drawer that's connected to the receipt printer, and we utilize the ability to have the draw kick language as part of the Epson printer here to issue a draw kick, which is a 24-volt signal that will fire a solenoid, which will open up our cash drawer. So if I click on my item here, you heard the cash drawer open, and now I could go in. It's unfortunately empty of cash. And then we could track alarms, and we could get information about that. And you can go do any combination of these type of things, but that gives you a contextual understanding of the type of experience that a customer would have in a real-world situation as they go through the steps of using those tools. So let's go back to the slides. And now what I'll do is go through some of those peripherals and the new features that we've added inside Windows 10. So I talked about the fact that we supported Barcode Scanner and Magstripe Reader. We did that for Windows 8.1. Now we're adding the receipt printer, we're adding the cash drawer, and we will be working closely with our partners Ingenico, Verifone, to enable UWP apps to build against pay stations and have that as a separate item that you'll actually be able to have these modern applications talk directly to. So in terms of how it looks from a developer perspective, what we have is the UWP applications will talk into the standard universal Windows platform, and then we have a namespace point of service that exists, and so you'll get access to classes through that point of service namespace. Underneath that, we have a device access broker so that multiple apps can be running on the machine at the same time, and you can go in and access those applications, access that hardware, and share it amongst different apps. Now, this will have some impact on what you as developers will need to do in terms of best practice in dealing with the fact that the hardware is not going to be exclusively owned by you unless you request that. And then underneath those different classes, whether it's Magstripe Reader, Barcode Scanner, POS Printer, or Cash Drawer, we have some individual driver support for things like MagTech and IDTech, Magstripe readers. We have support for Bluetooth drivers for barcode scanners, and we have support for Escape POS as a printing language that can be surfaced either over a wired or wireless Bluetooth connection. And then we go down, and you can go down through the items here, and in the middle, you can actually see underneath the POS printer, we go all the way down to Legacy Cash Drawer, where we'll actually go and use the items that I showed you here, which is that 24-volt signal off the back of the receipt printer. So now that we've looked at that basic architecture, I want to just go back to back to Visual Studio and give you a little look at there's a common API pattern that we have inside of the APIs across Barcode Scanner, across Magstripe Reader, POS Printer, and Cash Drawer. So the first type of thing that you'll do in the common pattern is that you'll just define a couple of items. You'll define a device, and then you'll define a claimed version of that device. Once you have that device, you'll go and say, well, get me the default or get me the specific device on the machine. So you'll go in, get default, get a specific barcode scanner if you have more than one. Once you have that, what you end up with is effectively a claimed device that now you can go and say, I own this device for this application for the purposes of my transaction. Then with that device, you can say, hey, turn on, please be ready to interact. And then you can, if you just scroll down here a bit, then you can go in and set up the events that you need to do to go and handle information and data coming in on those devices. So we will fire back to you once the device is there. And you can set up device properties inside these classes. Now, this is a common pattern that exists. So you'll see the same set of APIs for Barcode Scanner, the same set of APIs for Mag Stripe Reader, for POS Printer, with some additions, and for the cash drawer as well. So let's go back to the slides and take a look at each of those areas. In Barcode Scanner, this is one of the things that I said that we'd supported in Windows 8.1. For Windows 10, we've gone and done a lot of work to expose new interfaces inside the DDK for companies and customers, ODMs, that build actual barcode scanners and write the drivers. So now it's much easier for them to write their own driver that will be supported natively in UWP, compared to where it was previously, where we had to write a base driver and then we worked with only a few select partners to have the driver available. What we wanted to do here was to converge both the Windows and the handheld implementation when we did that work. Currently in 8.1, there's actually two different code paths that go on. We wanted to bring all that together, so now there's one set of APIs, there's one code path, one implementation, and you as developers will only need to experience that implementation as you go through. We also wanted to add support for Bluetooth scanners so that we can enable that theme of a mobile POS experience. Now, the APIs here I showed in my little walkthrough, the barcode scanner code. You know, you start off with a barcode scanner, you start off with a claimed barcode, a barcode scanner, you claim the barcode scanner, that gives you a claimed barcode scanner object, and then on that you have a number of items that you can call to enable it to go and do things, to set properties. One of the items that I didn't talk about was the release device requested event. As a developer utilizing this device, we talked about the device broker in the architecture slide. All of these devices can be shared, and that device broker will go and share across them. And you as devs should set up an event to handle the release device requested, so that when another application would come in and say, hey, I need that device, your app needs to be able to understand and set its state. Is it in the middle of a transaction that it needs to hold that device, in which case then you should deny the request? If it's in a state where it can give up the device, you can give up the device, and then your app should be ready and remember that it no longer has a claimed device, so it has to go through the device claim process before it can go and use that. And that release device requested is, again, that common event across all the different application API sets. Inside Magnetic Stripe Reader, and this has a build, I don't know why. Inside Magnetic Stripe Reader, probably the biggest thing that we did here is the fourth bullet actually on this slide. We support an OEM VID-PID compatible mode. Now, what that means is that OEMs will be able to take a base int file that we have and set their VID-PIDs on it and have that device, that Mag Stripe Reader, recognized by the system and recognized by us as the default, as a MagTech or an ID Tech or an OEM specific implementation of the Mag Stripe Reader. Why is that important? If you haven't run into this, the reason that it's important is that in a lot of cases, when you'll actually go and get a device from a manufacturer, like if you went to HP and bought a HP Elite Pad and got the retail jacket for it, the MSR that is on that jacket is actually just, I think, a MagTech MSR. Oh, actually, no, it's an ID Tech MSR. But HP gets that, they put their own PID vid into it, and then at that point, our driver doesn't load. And so it's difficult for you have to go get the HP driver, you have to wait for HP to update that driver to support the new platforms, and then you can start programming against that. In this case, by giving them the ability to create their own int file, instead of writing the driver and doing all that work and re-releasing it themselves, all they need to do is simply map their VID-PID to the underlying driver that was delivered from MagTech or ID Tech. And so getting an updated driver and getting that experience should be much faster inside Windows 10. We've also updated all of our sample code, so if you go up to the sites at the end of this presentation, they're all there in UWP application code, so you can see what they are and go build them. Receipt printer was a big investment. It's brand new inside Windows 10. And this is a complete WinRT API for a POS printer. We started off with the unified POS standard and then took that and created a set of APIs that map that experience from the unified POS standard. So the programming experience that you will have in there will closely map what the actual, what you've been experiencing today utilizing the unified POS standard. Initially, we wanted to support the Escape POS printer control language. That's widely built in. We'd already supported it. The majority of receipt printers have it. And we wanted to support network and Bluetooth receipt printers. And this enables you, again, to have that more mobile experience inside the retail types of environments that you'll actually build. The API set that you can see is very similar to what I showed in the Barcode Scanner, what I showed in Mag Stripe Reader. But there's a bunch of more APIs that you'll have because now you're actually controlling the output and what you would like to see printed on the device itself, on the receipt itself. So you'll have a bunch of properties around checking, is the cartridge empty, has it been removed, am I ready to print? You'll have an ability to set up a print job and define how, what type of line do you want? Do you want to print an image? Do you want to print a barcode? Do you want to print a bitmap? And you'll be able to set all that print job up and have it print directly to the printer utilizing these APIs. And this gives you a way of creating a rich output on the receipt printer and also to be able to tell the person that's actually utilizing the POS application that there are issues involved with the device if it's out of paper or ink or jammed or so on. For cache draw, I talked about the support for the legacy devices like this, which has a draw kick driver. We support that. We also support a new network and Bluetooth connected cache drawers so that you can have these items in that mobile experience where the cache drawer sits on a counter along with a receipt printer, Bluetooth connected to a device with, say, a retail sled that is being used on the shop floor. And when the commerce is conducted, it's actually driving those devices as you get back. There's no wires, no docking. And that was, again, another investment around the theme of enabling this mobile POS. The only difference really between that model of claiming, of enumerating, claiming, and then utilizing, in this case, is that we also have an additional alarm that you can set. And that's the property is that's the create, draw, close alarm method. What this does is enable your application now to set an alarm that will be fired if the cache drawer is left open. So when that cache drawer comes out, you can start a timer that will look to see that, okay, the cache drawer has been issued, certain period of time. Now I can fire an alarm reminding the person that's utilizing the POS system that they need to close that cache drawer. And this should help drive the security of the actual POS environment, the physical security of the POS environment more for you. So that's pretty much a quick overview of the existing, or of our new work inside Windows 10 for supporting retail peripherals. I'll hand over to Demet and Alex now to talk about NFC and host card emulation inside Windows 10.
Thank you. Thank you, Tony. Tony told this great story on the accepting side of the payments. Now I'm going to talk to you about how to make those cards that we use daily stored in an app. So at the beginning of the session, you saw me using my loyalty card to buy stuff that I really didn't want to. To just like get my back order items. And then you saw that I use my credit card stored in an app. I actually have more cards than that I use daily. So all of them are like listed here. That's great for me as a user. It's like there on my phone. I can use it anytime. But what about you? You as the merchant, line of business owner, bank, issuing these cards. You're issuing these cards to your customers. You want them to use it. In Windows Phone 10, we are enabling the APIs for you to be able to create experiences, unique experiences in your apps, and store these cards digitally on your customers' phones. With unique experiences, what can you do? you can actually push promotions, coupons, any type of incentives to your customer's smartphone at the time of the checkout. So you can reward them right then and there at the checkout process. As a result, your customers will be using these cards more often because there's less friction. You can get more information about your customers' behavior. You can even customize these experiences further, which will lead to customer satisfaction and increased usage. So to you, as a card issuer, merchant, this will turn into less costs due to little or no transaction fees associated with these cards, more efficient checkout process so that you can actually go through more customers during the busy time, as well as more information around your customers so that your customers will come into your store more often. So I'm going to walk you through an end-to-end user experience. In this case, there is a reloadable prepaid card on my phone. I drink my coffee in the Ford Coffee store, so I have the app installed on my phone from the Windows Store as any other application. So I'm going to walk this through as a payment card, but the concepts will apply to non-payment cards, such as badges or access badges. So the application will ask me to identify myself. I enter some type of identification, authenticate to the app. Since I already have a card from this merchant, you can push the card into the application. So it appears there. You can also use camera to maybe provision the card in the app, or whatever other ways you can find out, like maybe enter some numbers. At this point, the system knows that your application has a payment card hosted. So as a user, if I wanted to enable tap and pay, Windows will ask me for a consent. Since this is a payment card, we have this concept of default payment card and default payment app. That doesn't apply to non-payment cards. At any point in time, the user can have only one payment card enabled on their device. So I accept Ford Coffee card to be my default payment card. And now I can pay either by bringing the application in the foreground, or it even works when the screen is off, even if your phone is unlocked. So that's great for some scenarios, like if I'm going for a quick coffee for like $2, I can tap my device and it will go through under the screen. It might make sense a little bit for me to have my main payment card as a coffee card, because I live in Seattle and there's coffee stores everywhere. But for an average user, that might not make much sense. They would probably want to put their credit cards as their default payment instrument. How they can do that? One way is through the NFC settings menu. As the application notifies the operating system that there is a payment card associated and hosted in this application, the card name and the app name will appear in the NFC settings menu. If I select the menu, I can see all the other cards, payment cards, registered with all the other apps. As you can see here, we have two other options, which is none. And if the user selects that one, then the payment instruments will be turned off, but the non-payment, such as badges, will still work. I also mentioned that in Windows Phone 8.1, we enabled WinRT APIs for UICC, which is SIM-based applications. We continue to support that in Windows 10. So if you have an application hosted on the SIM card, you can select that. In this case, like a normal person, I'm going to select my credit card as my default payment card. So under the lock screen, in the black screen, when I tap, I know that my Contoso Bank credit card will go through. I'm going to go through the high-level view of the architecture. On your right side, you see the Windows OS, which will provide 3 main functionalities for your app. One of them is registration of your cards and persisting those registrations. The other one is conflict resolution. So there might be multiple apps registering for multiple cards. The system knows about that, and based on the user settings, it will resolve to one of the application during the tap process. It will also notify your application when there is traffic coming in from the NFC radio that is of interest of your application. Your application is a universal Windows platform application, and it needs to consist of 2 parts, the foreground app and the background task. I'm going to go through that in the next slides. Your foreground app has the UI. It also registers for the applet IDs, applet identifiers, called AIDs. That's the mechanism for Windows to know which application to wake up at the time of the tap. After your application tells the OS that this is the card, this is the AID, it will ask for the activation policy to be enabled so that your application will receive the traffic. At this point, system will start listening application protocol data units, APDUs. This is a standard way of the cards talking to the external NFC terminal. This is how it's also working with the plastic card. So your app will be talking to the external terminal using APDUs. When an APDU that is of interest of your app comes in, Windows resolves it and wakes up your background task. Your background task is responsible for sending responses to the external terminal. Optionally, it can launch a foreground app, such as like a UI or the one that you see, in my case, that the receipt for the transaction. So I'm going to go through the foreground app in a little bit more detail. What is an applet ID group? Applet ID group is a group of AIDs that are logically belong together. So whatever applet IDs in a plastic card, you put it in an applet ID group. It has 4 main properties. The first one is the display name of the applet ID group. That's the name of the card that appears in the drop-down menu that we see in the NFC settings. It also appears in the prompts to get consent from the user. An applet ID group has the applet IDs listed, which are 5 to 16 byte identifiers for the applets. An emulation category, we have 2 different emulation categories, payment and non-payment, which is called other in the system. And the emulation type, as explained, in Windows 10, we support both host card emulation and SIM-based emulation, which is UICC. After you construct your applet ID group, your application will register it with the system using the applet ID group async registration and get a registration object. And using the request activation policy method, it will call to enable so that your application will start receiving the traffic. It's at this point that the user might be prompted. What about your background task? Your background task will receive the traffic coming from the external terminal. When a user taps their device onto a payment reader or NFC reader, the first command comes from the NFC reader and resolves to your application. At this point, the reader is waiting for your application to return a response. So it's recommended that your background task is fast and doing very lightweight operations. think of a tap as like the users won't be holding their phones on the reader forever. So during the tap of this instantaneous event, there will be multiple command response pairs that's going back and forth. You can respond. You can actually get the command coming from the reader by reading the command APDU property and then responding with a try respond async response. When the user pulls their device from the reader, you'll get an event. Also, if the reader would like to talk to another application, you'll get an event. At this point, you will need to exit your background task as soon as possible so that another background task can run. So last two features that we added are lock screen behavior. It's very useful if I want to do a quick coffee buy or a quick transaction that I don't have to turn on my phone, unlock my phone, bring the application in the foreground. What you can do with your application in your implementation is that when the user taps, you can wake up the phone, and you can launch your foreground app onto the lock screen. At this point, the phone is still locked, but the transaction will go through, and then you can show any type of UI to your users. Also, we provide the foreground override. As you saw, I set my Contoso credit card as my default payment card. So whenever I tap, it will go through. But when I go to my coffee store, I want to use my coffee app because I get rewards on that. So what I can do as a user is that I can bring the coffee app into the foreground before I tap. Your application, whenever it comes to the foreground, can ask to be foreground override. So as long as your application is on the foreground, the traffic will be received by your application. The phone settings will not change. My Contoso credit card will still be my default payment application, but this is a temporary override where your application can receive traffic. So with this, I'm going to hand off to Alex, which he's going to show some cool demos of the sample application that you all will be receiving.
Thanks, Demet. So you guys saw some cool scenarios, and you probably want to see it actually working for real. We showed it earlier in the demo on a real phone, and what I'm going to do is show you a demo in the Windows Phone emulator. So you can see I got a bunch of buttons, and Demet took you through the high-level overview of what you have to do. So the first thing is register a background task. So I'm going to hit that, register my background task. I'm going to add a payment card. So let's just add something like that. And this is just an example. And then I will enable that card. Because by default, when you add a payment card, when you add an applet ID group, it defaults to being disabled. You have to explicitly enable it. So I'm going to hit enable there. And because this is a payment card, Windows is going to ask the user. So this is system UI saying, hey, user, do you really want this to be your payment app? And if there was a previous app that was previously your default, Windows will warn the user, hey, this app wants to be the default, and it means your old one will no longer be the default. So I'm going to accept that. So now that's enabled. So one thing we've added in the latest version is, although we had a tool that we open sourced in 8.1 that only did proximity, we've now got full support in the NFC emulator, in the Windows Phone emulator for NFC. So you can simulate all aspects of NFC. Not only HCE Tap and Pay, you can simulate proximity, the smart card reader-writer mode to send raw commands to any different type of card. And for the HCE simulation, how it works is that you write C# code in this box here. So you can basically implement the reader side of the code in C#, any kind of C# code you want. You pretty much just construct your APDUs, run the send method. It sends it into the phone as if it came from a real physical reader. The phone responds, and then you can look at that response and then decide how to process the next one. So I'm just going to do a quick try. Let me clear those. So if I just hit the play button, it's going to run and do a credit card transaction. So you can see the phone popped up, and you can see all the traffic here. So here are all the APDUs and the commands, and so you have a full log of what's going on. So this will work for anything, not just credit cards, but debit cards or door access or transit passes, whatever you'd like to use it for, anything that uses APDUs, you can use this built-in emulator. The other thing I'd like to show you is that it's great that we have this flexibility. We can write any C# code you want as the reader side. But what if you're making a credit card application like, let's say, a MasterCard application, and you don't want to have to implement the entire reader, and it's very complicated sometimes to get everything just right exactly as a real certified reader would do it. And you don't want to write all that C# code yourself. Well, luckily, the folks at MasterCard, they have a product called Terminal Simulator, which is a free download from terminalsimulator.com, so you can get that from MasterCard. It, of course, only works with MasterCard cards. And so what we've done in the Windows Phone emulator is add some connectivity between them. So I'm just going to click this checkbox here in the Windows Phone emulator to enable the MasterCard feature in the Windows Phone emulator. And then the only other thing you need to know is that after you install the Terminal Simulator and after you install their expiration update, you click on the B3 button and you check the remote reader box. So that's the only and hit update. So that's the only kind of tricky thing you've got to know about how to enable this feature. And then I'm just going to put in, a couple dollars and hit the green button, and bam. You can tell it's a real demo. So, but this is, again, here is a full trace of all the APDU commands that were sent over the wire by the MasterCard simulator. Also, look at all this data that the MasterCard simulator has for you. It lets you debug. If there's a problem with your app, you see everything here, and it's all parsed, and it tells you exactly what's going on. The other great thing is that the Terminal Simulator connects with the MasterCard Issuer Simulator, which is basically playing the role on the bank side. It's validating the crypto. So the Terminal Simulator simulates sort of everything on the merchant side at the point of sale, and the Issuer Simulator simulates everything that would be going on at the bank when that merchant sent their data up to validate that it was a real credit card with real crypto and that the keys all match and that everything checks out. So you can simulate the entire end-to-end stuff for free right now with all the tools that are available with the Windows Phone emulator and the MasterCard simulator. The next thing I'm going to show you is that we released some sample code a couple days ago, and it's all part of the Windows 10 universal samples on GitHub. And you can download that right now. That sample code is really meant as a way to get you to understand the platform and how to use our APIs. So it's not meant as a pre-certified or anything like that. It's just example code. And I'm going to take you through some of that code. And so the first thing I'm going to show is that in your application, probably one of the first things you want to do is you want to check if the phone actually supports HCE. So newer phones generally, the newer models, if they have NFC, they generally support HCE, but there are some older phones where even if they have NFC, they don't necessarily support HCE. So what you want to do is check that. The other thing as well is that currently HCE support is only on the mobile SKU, on phones. So the first thing you're going to do right here is you're going to check if the API is even present on the platform you're on. So you're going to check whether that API exists. The next thing you're going to do is find out, is there any type of smart card emulation support? So if the smart card emulator.getDefaultAsync, if that returns null, it means there's no emulation support of any kind on the device. Next thing you're going to do is check is host card emulation supported, the Boolean. If it returns true, you're good to go. Also, there is a way in the store so that you could optionally filter your app so that people whose devices don't support HCE won't see your app in the store. They could still override it and click through the warnings and manage to install it. But you can at least not tease people whose devices don't support it. The other thing, the next thing in the code is even if their device supports HCE and all that stuff, you want to check if the user actually has it enabled in the control panel. And that's something the user has to switch on. We don't allow apps to be changing around the user's settings. But what you can do is check the enablement policy. So if the enablement policy is set to never, it means the user has it disabled in their settings. So what you need to do is, if that's the case, tell the user what's going on, and then you can jump them straight to the NFC settings panel here and ask them to turn it on. And then when they jump back to your app, you can check again, and it should be back on. After that, you're going to register your background tasks. So there's two different types of background tasks you can register. So one is, the first one here is for HCE. So this is the background task which actually receives those APDUs when you tap. The other background task you can register for is this registration change. So that's in case you want to be notified if the user ever changes what their default payment card is, or if some other application has been installed that disables you, because maybe there's a conflict of AIDs, something like that. So you will be notified anytime your cards, any of your cards, go from being disabled to being enabled without going through your app, or from enabled back to disabled. So you can update live tiles and that kind of thing. And the implementation for registering a background task is here. And it's just a standard background task. So you register it just like any other background task. It's of the type smart card trigger. So if you're familiar with background tasks, it's pretty straightforward. The next thing you're going to do after you got your background task set up is actually register your AID groups. So these are effectively registering your cards. So telling the system what cards you've got. So you put in display name, a list of applet IDs, whether it's a payment card or non-payment, whether it's UICC or host-based, and there's a few other settings you can control. So the actual implementations here, it's pretty straightforward. You just create it and then register it with the system. And like I mentioned, by default, it's not enabled. So you're going to have to actually enable it by calling the request policy change and tell it you want it to be enabled. And then the other thing I'll mention is that in the sample code, we've implemented the background task code in C++ CX. So while the foreground app is all C#, the background task is C++ CX. The reason is performance. So normally C# is extremely performant, fast for almost everything. But we recommend C++ CX specifically for the NFC background task, simply because the performance requirements are so tight. For payments, you're looking at wanting to get it done within maybe 400 milliseconds. And so in order to get that, C# adds a little bit of startup latency. So the recommendation is your entire background task, including anything your background task depends on or references or includes as a library, ideally would be native code. So that's why we've got the sample code like that. So here is the run method of the background task. The first thing we're doing here is actually checking if the screen is locked, because the OS will launch you even if the screen is locked. It's up to your background task to decide if it wants to implement any security on top of that. So in this sample app, we're checking, is the screen locked? If it is, it's a user configurable thing of whether to deny it right away. And then the other thing you can do is that, so for example, if it was denied, if the screen was locked, you can launch your foreground at any point by using this function on the trigger details. And you can choose to either launch it above the lock screen if the phone is locked, or the default behavior, which is that if the phone is locked, it'll prompt the user to unlock their phone first. And the only thing is just be careful when you're launching something above the lock screen. Make sure your application doesn't have some way to, get around it and then show personal information. So be aware, if you do use that feature, you need to be very careful. So the next thing you're going to do is register for the event handlers. So there's a couple of them. APD received is fired when you get an APDU in. And then the canceled and connection deactivated event are ones where, in general, you want to end your background task pretty much as soon as you get those. And try to minimize any cleanup that you need to do, but obviously gracefully clean up. So in general, in a background task, you would complete your deferral. So you'd take a deferral at the beginning of your background task and complete it when you get any one of these events. And then you're going to start the emulator. So starting the emulator just means that the OS knows it's safe to start sending you those events. So in an APD received event, we get in some event args. And those have the actual command that came in from the remote reader. And so we're going to have our own little function here to process that command and to figure out what we respond it with. And then we're going to call try respond async to send back the response to the reader. And this event will fire multiple times for as many commands as the reader sends. So with that, I'm going to turn it back over to Demet, and she'll tell you where to get all these tools.
So this concludes our session. We told you a story about how you can use Windows devices on the receiving side of retail and how you can use devices to digitize the cards that you're issuing for your customers. So please, please sign up for Windows Insiders. Download Windows 10, check it out. Check out our sample code, both on the IoT side and on the NFC HCE side. It'll get you started very, very quickly. We also have released the developer tools. Download them, play around with the emulator. We have great features going on with the emulator. So you can check out some of the build talks, especially on the NFC HCE side. We touched a lot around the background task. So there was a talk, I think it was on Wednesday, by Sean, that talks a lot about background tasks. We are also releasing a development guide that if you follow these links, you can reach our blog and ask us more questions. And please evaluate this session. We want to know how we did, and we want to do better next year. So with this,
Yeah, we've finished a little early. We have two options. You can all make a mad rush to get out of here, or we can do some Q&A. I think it's probably best, if you want to ask Q&A, just come on down the front here. For those of you that want to leave, I really do want to thank you for coming here and spending some time and listening to our retail story, and for attending Build and the public availability of all the stuff that we've done at this conference. Thank you very much.